In August of 1984, something very strange and very scary happened in a very remote part of Africa. Lake Manoun is a small, bone-shaped lake in a rural part of the country of Cameroon, nearby to nothing that most people from the outside world have ever heard of. Surrounded by farms, a small village immediately to the northeast, and a small local road running just to the east, Lake Manoun was always a quiet, rustic, and obscure location until it was struck by an unprecedented nightmare. Late on one August night in 1984, local villagers around Lake Manoun would later report that they heard a loud rumbling noise, but hardly anyone thought anything about it at first. At around 11:30 p.m. at night, a mysterious cloud of white mist shot up out of the lake, and then poured across the road immediately to the east of the lake. By the time the sun began rising the following morning, the mysterious cloud remained across the road, and villagers from the town just to the northeast began waking up and traveling down the road to go to work, directly through the mysterious cloud. Assuming that the cloud was just some unusual morning mist, hardly anyone thought anything about it and simply traveled through it, only to find that immediately after they entered it, they could no longer breathe. Gasping for air and immediately suffocating, anyone who entered into that cloud that morning along that road would be dead within only a single minute. Eventually, by around 10:30 a.m. in the morning, local winds had swept the deadly cloud away. And then, to everyone's horror, the number of unfortunate victims who had entered into the cloud over the preceding hours became immediately apparent. Eventually, a local police officer and a doctor arrived to the scene, where they discovered the bodies of 37 people strewn across the road who had been killed by the mysterious mist. Some of them who had walked, and others dead in their cars, and at least one man dead slumped over his motorcycle. All unfortunate enough to have chosen to walk or drive through what they thought had only been a cloud. In the immediate aftermath of this incident, there was no good explanation for what had happened. Some superstitious local villagers believed that the lake was cursed and contained evil spirits who came out to kill the victims that morning, while the Cameroonian government initially suspected that the incident was a chemical weapons attack committed by terrorists or rebels attempting a coup d'etat. But the chemical weapon explanation didn't really make any sense. Chemical weapons are a difficult thing for anyone to actually acquire, and even if some group of rebels in Cameroon had actually somehow managed to acquire them, why would they have wasted them attacking a random, rural road in the middle of nowhere rather than a more valuable target? And why had nobody claimed any responsibility for it? The search for an explanation quickly turned to the search for a natural cause, and some people quickly began pointing to the existence of the Cameroon Line, a volcanic chain of islands and mountains that spans from the Gulf of Guinea into the West African interior, directly through the location of Lake Manoun, which sat directly above one of the volcanoes in this chain that had long been believed to be dormant. But perhaps there was a chance that it had reactivated again and had triggered the disaster. And so, the American embassy in Cameroon summoned an expert named Haraldur Sigurdsson to come to the country and investigate what had taken place at Lake Manoun. Sigurdsson was a well-respected Icelandic volcanologist and geochemist who at the time worked at the University of Rhode Island in the United States. He eventually arrived at the scene of the Lake Manoun incident in Cameroon many months after it had happened, and he began conducting a plethora of tests to try and get to the bottom of what had killed 37 people there. But Sigurdsson quickly found no evidence that a volcanic eruption had recently taken place in the area, and frustratingly, he found very little other evidence of just about anything else natural having happened either. The lake bed beneath the surface showed no signs of having been disturbed. He discovered no sulfur compounds that would have indicated a volcanic eruption, and he found no signs that the water in the lake had ever even recently increased in temperature. The eureka moment for Sigurdsson only came after he lifted up a bottle with a water sample inside from deep within the lake. After the bottle reached the surface, its lid popped right off like a shaken-up carbonated beverage might do. Sigurdsson realized after that the water from the deeper depths of the lake was absolutely saturated with dissolved carbon dioxide, or CO2, as if it was a massive bottle of carbonated water like LaCroix. And it was shortly after that when Sigurdsson also realized that the deaths of those 37 victims who had entered into that mysterious cloud were all consistent with carbon dioxide asphyxiation, which in its gaseous state is colorless, odorless, and heavier than air, which he theorized was why the CO2 cloud had remained so low on the ground for so long. CO2 is also extremely deadly in its gaseous state, and it'll kill people rapidly in the same way as what happened to the victims around Lake Manoun. Sigurdsson then began expanding on this theory, attempting to explain how dissolved CO2 in the deep waters of the lake could suddenly transform into a cloud of deadly gas above the lake. For For the next nearly 2 years, Sigurdsson steadily developed and expanded on his theory. He eventually concluded the Lake Manaun was, effectively, a highly bizarre geologic anomaly. He theorized that magma from deep beneath the lake bed had been slowly degassing and allowing CO2 to percolate up into the lake's lower layers for decades or even centuries, where the CO2 would dissolve and mix with the lower, heavier, cool waters and remain trapped by the lighter, warmer waters above in the lake's upper layers. This isn't a problem in most lakes because most lakes' waters frequently mix together and prevent this steady buildup of CO2 in the lower lake layers from being possible. During the winter, the surface water of lakes grow colder and denser and sink, and so they shift the lower, warmer, lighter, and less dense layers up to replace them. While in the spring and summer, the opposite process ends up happening too, which keeps the layers of the lake constantly shuffled around. Lake Manaun, however, is located near to the equator within the tropics, where the climate remains warm throughout the entire year and never shifts, meaning that this usual process of layers mixing together within lakes throughout the procession of the seasons doesn't really happen, meaning that the lower layers of lakes in the tropics will often remain stagnant for multiple centuries at a time. Sigurdsson theorized that in the specific case of Lake Manaun, the CO2 percolating upwards into the bottom of the lake was probably causing the trapped lower layer of water at the bottom of the lake to steadily grow more and more saturated with CO2 over a very long time frame, and that it was only all contained by the warmer, lighter layer of water above it that acted like a cork on a bottle of champagne. The moment that something disturbed that cork, or after the lower layer of water reached maximum CO2 saturation, he theorized that the upper and lower layers of the lake would suddenly and rapidly shift, and that all of that pent-up dissolved CO2 at the bottom of the lake would rapidly erupt into its deadly gaseous state and kill everything unlucky enough to be nearby. Lake Manaun, in other words, had potentially been a slowly ticking time bomb for centuries, completely and insidiously impossible to detect by the people who chose to settle around it. Sigurdsson referred to his theory of what had happened at Lake Manaun in 1984 as a hitherto unknown natural hazard that had the potential of annihilating entire towns. And in 1986, 2 years after the Lake Manaun incident had happened, Sigurdsson submitted his entire study and theory as a paper to the prestigious journal Science, which rejected it on the grounds that it was too far-fetched. Sigurdsson's theory thus remained extremely obscure and niche, known only to a small handful of his fellow experts in his own field. But only for a few more months, because astoundingly, only about 100 kilometers away to the northwest of Lake Manaun, there was another one of these ticking time bomb lakes in Cameroon that nobody was aware about that was also, almost impossibly coincidentally, at that very moment also on the verge of exploding as well. And this one was going to be orders of magnitude more deadly than what had happened at Lake Manaun. As the sun set on the evening of the 21st of August of 1986, the small villages around Lake Nyos in Cameroon were calmly quiet. At about 9 p.m. that night, a few of the very small handful of people who would survive what was about to happen would later report that they heard a loud rumbling sound, consistent with eyewitness reports from what had happened just before the Lake Manaun incident as well. Many of the villagers around the lake had already gone to bed, completely unaware of the enormous danger that was imminently about to bear down on them. Suddenly, with little warning, like what happened in Lake Manaun, a massive cloud containing up to 1 cubic kilometer, or about 300,000 tons of carbon dioxide, erupted out from the lake in a deadly, low-lying, thick white mist. Scientists who investigated the site later found evidence that the gas eruption from the lake also triggered a tsunami about 25 meters high that crashed onto one of the lake's shores. The cloud of CO2 gas initially shot up at a speed of nearly 100 kilometers an hour from the lake, but since it was heavier than the air, it rapidly collapsed back down onto the nearby villages around the lake's rim and then poured down into the lower-lying valleys and into multiple smaller villages nearby, carrying death with it as far away as 25 kilometers away from the lake. Within the closest 2 villages to Lake Nyos at the time of the eruption, called Nyos and Kam, only 4 people who were fortunate enough to be located on higher ground managed to survive the low-lying toxic cloud. A few people in some of the villages were initially fortunate enough to have only been rendered unconscious by the CO2 cloud rather than killed by it. Some of them remained unconscious for as long as 36 hours. before suddenly awakening to the unbelievable horror of finding that their entire families and all of their neighbors were all dead. Many who survived the cloud were left with permanent respiratory problems, lesions inflamed on their skin, and even paralysis in a few extreme cases. Over the next couple of days following the eruption of Lake Nyos, the survivors and people from surrounding areas began entering into the valleys around the lake to discover what many of them legitimately believed to have been the apocalypse. The cloud that had thundered out from Lake Nyos that night had ended up killing a total of 1,746 people across the night as if it were a biblical plague. Nearly 50 times as many people who were killed by the similar gas eruption from Lake Manaun only a couple of years previously. The cloud also spared no life whatsoever as it spread around the lake that night, claiming the lives of humans and animals alike. Around 3,500 cattle were also killed by the cloud, their carcasses left behind, adding even further to the overwhelming sense of devastation. As people began entering into the scene over the next couple of days and discovering the hundreds of bodies and dead cattle strewn all about, one of the eeriest things that they began reporting was the utter quietness and the lack of flies on any of the bodies or carcasses. Because the cloud was so lethal, it hadn't even spared any of the insects either. It was an event of almost complete localized annihilation of all nearby life, a miniaturized extinction event. To make the whole scene appear even more apocalyptic, the lake itself, usually a picturesque blue, had turned completely blood red and looked like rusted out iron. The sheer scale of this disaster around Lake Nyos understandably attracted significantly more attention from the outside world than the much smaller disaster that had taken place at Lake Manaun only a couple of years previously. And it quickly introduced the theory to the world that Haraldur Sigurdsson had brought forth and attempted to have published in Science just a few months beforehand. Scientists and researchers from all around the world came pouring into Cameroon and descended on the location of the disaster zone around Lake Nyos in the weeks and months that followed. And they steadily began to piece together what had happened there from the evidence that was available. Just like at Lake Manaun, Lake Nyos was a very similar geological anomaly. A lake in the equatorial tropics that sat above a volcanically active area, with a lower, cold, and heavier stagnant layer that had been quietly building up in CO2 concentration through underwater springs for potentially centuries, and a higher, warmer, and lighter layer of water that acted as the cork on the bottle. The exact reason for why Lake Nyos erupted and killed nearly 1,800 people that summer night in 1986 has never been conclusively proven. But the leading theory is that a landslide of boulders could have crashed into the lake, and that could have been enough to disrupt the layers and to have triggered the dissolved CO2 at the bottom to rush up to the surface and explode into its toxic gaseous state. It was noted that many of the surviving local residents reported hearing a loud rumbling or crashing noise just before the toxic cloud had appeared, which could have been them hearing a landslide, while several of the researchers who arrived afterward observed that one of the cliff faces adjacent to the lake did show signs of a fresh rock slide. Other alternative theories for the potential trigger of the disaster include a sudden drop in air temperature that might have cooled down the surface water and caused it to suddenly drop and mix in with the lower CO2-rich layer, triggering the explosion in the process. Or a sudden gust of strong winds or cool, heavy rainfall that might have all done the same thing. Whatever the cause, the disaster at Lake Nyos showed the world that Sigurdsson's theory of a hitherto unknown natural hazard was correct, and that something that was initially believed to only exist in myth was in fact very terrifyingly real. These kinds of lake explosion disasters eventually acquired the name of limnic eruptions. And most alarmingly, the scientists who arrived to investigate the scene around Lake Nyos discovered that the 1986 explosion had not actually removed all of the pent-up dissolved CO2 down at the bottom layers of the lake. And neither did the 1984 explosion at Lake Manaun either. In fact, in both instances at Lake Nyos and at Lake Manaun, the concentration of CO2 in their lower layers were still continuing to increase, leaving the possibility that both of the lakes could cataclysmically explode and kill again in the future. In order to solve this problem and to remove the dangerous CO2 from the lakes, the researchers involved came up with several different ideas, some more outlandish than the others. One idea put forward was to dump an enormous amount of lime into the lakes using helicopters in order to neutralize the gas, but that was considered to be too expensive. Another idea put forward was to simply blow out the CO2 from the lakes by dropping bombs into them, but that was considered to be too dangerous. While still another idea was to dig out a series of channels or tunnels from the bed of the lake in order to drain out the CO2 heavy water from the bottom, which was considered to be far too expensive of an option to try. Eventually, the researchers decided to take one of the cheapest and low-tech options to remove the CO2 from the lakes instead. In 2001, they simply placed a floating dock on the lakes, and used a pipe that was placed into the lakes that connected the lower CO2-laden water layer with the surface, and released the CO2 heavy water through the pipe up to the surface, basically as if it were a natural geyser. This allowed the CO2 gas at the bottom of the lakes to safely vent upwards in a miniature, controlled version of a limnic eruption that steadily drained the lakes of their dangerous CO2. Additional pipes were added later to speed the process up, and eventually by 2009, Lake Manaus was considered to be fully and safely degassed, while the larger Lake Nyos was eventually considered to be fully and safely degassed as well a decade later by 2019. But just as both of these lakes were being rendered safe from the hitherto unknown natural hazard of limnic eruptions, it was becoming clear that there was still another third lake in equatorial Africa that contained all of the same conditions to eventually explode, just like Lake Manaus and Lake Nyos as well. And this third lake was way more potentially deadly and apocalyptic. The exact conditions required to make a lake susceptible to limnic eruptions are very rare. They can basically only exist within a narrow band of the world where the tropics converge with tectonically or volcanically active areas, and in regions at not too high of altitudes that experience colder temperatures, while the lakes themselves have to be deep enough to have distinctly separated layers of water within them that aren't too disturbed by natural phenomenon. These conditions are so rare and far and few between that only one other lake in the world has ever been discovered since the 1980s that is also susceptible to limnic eruptions. Lake Kivu, in between the countries of Rwanda and the Democratic Republic of the Congo, or DRC. Lake Kivu is a part of the African Great Lakes region in eastern Africa, and compared to Lake Manaus and Lake Nyos that are thousands of kilometers away in Cameroon, Lake Kivu is a monster. Lake Nyos is relatively small at just about 1.7 kilometers long by 1.5 kilometers wide, and it's only about 213 meters deep. In comparison, Lake Kivu is nearly 50 times a bigger lake than that, measuring more than 88 kilometers long by 48 kilometers wide at its widest point, and with more than double the depth, reaching down to 475 meters below the surface. Similar to how Lake Manaus and Lake Nyos exist along the tectonically active Cameroon line, Lake Kivu also exists along the highly tectonically active East African Rift Valley, where the African continent is slowly being pulled apart by tectonic forces that'll eventually, in several million years, create a new ocean in the middle. The enormous stresses going on beneath the surface here have thinned the Earth's crust and unleashed volcanic activity, which has created hot springs just beneath Lake Kivu that percolate CO2 up into the lake's lower, colder, and heavier layers. Just like what was happening at Lake Nyos and at Lake Manaus, but on a vastly larger scale. Lake Kivu is also a lot more geologically older than either Lake Nyos or Lake Manaus are, which means that the soil that surrounds Lake Kivu is also much richer in organic material. Lake Kivu has a lot of microorganisms down in its lower layers that consume and digest this organic material and produce methane, while the same volcanic processes beneath the lake bed that release CO2 into the lake's lower layers could also be releasing additional methane into the lake's lower layers as well, a process that was totally absent at Lake Nyos and Lake Manaus, and which makes Lake Kivu's situation potentially far deadlier. For one thing, methane is a lot less soluble than CO2 is, which makes it much closer to reaching its saturation point in the lake waters than CO2 when bubbling out to the surface, potentially triggering the catastrophic explosion much quicker than with just simply CO2. Moreover, methane is also extremely flammable, leading to the risk that if Lake Kivu ever erupted in a similar fashion to Lake Nyos and Lake Manaus, the cloud released could be full of both CO2 and methane, and it could potentially ignite, sending out an enormous cloud of both toxic and flaming gases that would suffocate and burn anyone and anything unfortunate enough to be nearby. Lake Kivu contains multiple separate distinct layers of water density within it, with the lower, cooler, and heavier water layers containing the higher concentrations of dissolved CO2 and methane coming up from beneath the surface, and the upper, warmer, and lighter water layers acting as basically the cork on the colossal bottle of champagne. Each of these layers are separated from each other by only extremely thin border areas that are just a few centimeters thick. And because of the constantly warm climate the lake is found in equatorial Africa, these layers rarely ever mix with each other, keeping them all stagnant for entire centuries at a time, and leading to a steadily building ticking time bomb beneath the surface as the CO2 and methane layers continue growing denser. As with Lake Nyos and Lake Manaun, there are a few different triggers that could potentially result in Lake Kivu exploding in a similar fashion. The CO2 or methane in the lower layers could eventually just reach their saturation point, at which point any additional CO2 or methane released into the layers would immediately bubble into their gaseous state and rise up to the surface and trigger the explosion. A large kinetic event hitting the lake could also force the deeper gas-rich layers to mix with the upper lighter layers, reducing the pressure and forcing the lower gases to quickly come out of solution and bubble up to the surface and escape and explode. Lake Kivu is such a huge lake that a single landslide into it would probably never be strong enough to actually trigger the entire lake to explode in the same way that probably happened at the much smaller Lake Nyos. But there are other larger-scale natural events that possibly could happen here that would. Within a seismically active region, earthquakes are a common enough occurrence here. While they usually measure between a magnitude 4 and 6 on the Richter scale here, stronger ones still happen every now and then. Back in 2008, a 5.9 magnitude quake struck on the western shores of Lake Kivu itself, while in 2005 a 6.8 magnitude quake struck nearby Lake Tanganyika on the border of the DRC and Tanzania. And a little further back in time in 1990, a more powerful 7.2 magnitude quake struck in modern-day South Sudan near the city of Juba. If a powerful enough earthquake were to ever strike around Lake Kivu, it's conceivable that it could generate powerful waves within the lake that could disrupt the lake's layers enough to release the trapped gases down below at the bottom, and trigger the explosion in the process. A still even more alarming possibility that could trigger the explosion is a severe enough drought in the region. If Lake Kivu's water levels diminish far enough during an especially dire dry period, the layers of the lake could become more exposed to major disruption during a freak especially heavy rain event, potentially triggering the explosion again, and potentially making the risk of an explosion even greater in the future with climate change. Regardless of what might end up triggering the disaster that's hiding underwater in Lake Kivu, if it ever does become triggered, the result would be unbelievably apocalyptic. When Lake Nyos detonated in 1986, it's believed that the explosion released around 1 cubic kilometer of CO2 that killed more than 1,700 people. By contrast, it is believed that the lower layers of Lake Kivu contain around 300 cubic kilometers worth of dissolved CO2 and another roughly 60 cubic kilometers worth of dissolved methane. Put another way, Lake Kivu is believed to contain about 2.6 gigatons worth of dissolved CO2 inside of it. If that amount of gas is released during a limnic eruption of Lake Kivu, it would release, in less than 24 hours, roughly 5% of the entire planet's collective annual greenhouse gas emissions, all concentrated just in one small location. Worst of all, the shores around Lake Kivu are much more densely populated than the rural areas around Lake Nyos and Lake Manaun were. There are around 2 million people who live around the shores of Lake Kivu today, including 2 major cities on the lake's western shores called Bukavu and Goma that are both dense urbanized areas home to hundreds of thousands of people apiece. If Lake Kivu ever explodes the same way that Lake Nyos and Lake Manaun did back in the 1980s, it could literally kill millions of people in less than 24 hours. And thus, it contains the potential to be the deadliest natural disaster to ever happen in all of human history if it ever does. Interestingly, there's also a great deal of scientific disagreement as to how many times Lake Kivu has previously erupted in the past, or even if it's ever actually erupted before at all. Lake Kivu is known to contain 9 brown layers within its sediments, but the interpretations of what those layers actually mean differ from expert to expert. Some experts say that while sediment layers do show mixing events in Lake Kivu's layers over the past 2,000 years, there isn't any evidence to actually suggest that a large limnic-style eruption event has ever happened here in at least the past 12,000 years. But other experts argue that the evidence shows there has been at least one limnic eruption-style event that happened in Lake Kivu around 4,000 years ago. So maybe a previous eruption has happened fairly recently, geologically speaking, or maybe not. Confoundingly, there's also a great deal of scientific disagreement on how risky and how soon another explosion could take place at the lake in the future. There is a paper that was written back in 2005 by environmental scientists Martin Schmidt and Michel Halbwachs, who both have extensive experience with Lake Kivu, which compared the levels of gas saturation in the lower layers of Lake Kivu with measurements that were taken 30 years previously, back in 1975. Their paper suggested, and the key word here is suggested, that the level of methane concentration in the lower levels of the lake had increased by about 15% over that 30-year period. They then wrote that if that same speed of progress in methane buildup continued, the lower layers of Lake Kivu would reach their full methane saturation point by some point around the year 2090, which would likely trigger the cataclysmic eruption by then. But then, another much more recent paper that was written in 2020, with Martin Schmidt, one of the main authors of the 2005 paper, also co-authoring this paper, suggested that the levels of methane in the lower layers of the lake actually hadn't increased at all, so who really knows? That being said though, there also appears to be a high degree of controversy surrounding this more recent 2020 paper too. Some researchers have argued that the paper didn't actually prove that there were no changes in methane levels over time, but that the paper only showed that a change couldn't actually be detected. Which again, basically means who really knows what's actually going on. There have been many different methods put forward by scientists and researchers on how best to make Lake Kivu safe. But the problem with making Lake Kivu safe is that Lake Kivu is simply enormous, and it'll require way more work than what it took to make Lake Nyos and Lake Manaun safe. And unlike those other lakes in Cameroon, Lake Kivu is smack dab in the middle of a major geopolitical conflict zone. The western side of Lake Kivu in the DRC is, currently, completely out of the control of the actual DRC government and is totally under the control of non-state rebel factions. The largest and the most powerful of these rebel factions on the western side of the lake is known as M23. They are fairly blatantly directly supported and armed by Rwanda, and they fairly recently overran the major cities of Goma and Bukavu, capturing the two largest cities located on the lake and killing thousands of people in the process. This makes monitoring the CO2 and methane levels in the lower levels of the lake effectively impossible on the western side right now, since the entire western side is effectively a war zone and completely outside of the control of the DRC's government. Nonetheless, the Rwandan government maintains what is considered to be a very robust monitoring system of the gas levels and seismic events in the lake over on the eastern side, so a sudden upwelling of the gas wouldn't exactly come as a surprise. And eventually, the Rwandan government also realized that the high concentration of methane in the lake presented a great risk, but also a great opportunity, because methane can be burned for electricity. In 2008, Rwanda launched a pilot program to begin harvesting methane from the bottom of the lake and burning it as natural gas. And then a much larger project doing the same thing called KivuWatt started coming online in 2015. KivuWatt is a British-owned private company that operates on Lake Kivu's eastern shore with the permission of the Rwandan government. At a price of $200 million to get up and running, KivuWatt has managed to set up an operation on the lake where they pump up methane-rich water from the lake's lower layers, separate the methane from the water, and then pump the methane through a pipeline to the land where it's burned for electricity and power plants. And then they pump the now safe methane-free water back down into the lake's lower layers. This process accomplishes two different objectives for Rwanda. It provides the developing country with preciously needed fuel for electricity, and it also slowly removes the methane from Lake Kivu and reduces the odds of a limnic eruption eventually happening. Currently, the KivuWatt operation provides roughly 26 megawatts of electrical power to the Rwandan electricity grid, providing roughly 9% of Rwanda's total electricity supply. In the future, KivuWatt plans to expand their operation to the point where they will be producing more than 100 megawatts of power, which is roughly 1/3 of Rwanda's current total electricity supply, which makes the KivuWatt operation a very big deal to Rwanda's plans to develop themselves. But the pace at which KivuWatt is actually removing methane from the lake is very slow. At the company's current pace of extraction, they'll only be able to remove less than 5% of Lake Kivu's methane over the next 25 years. Even further, there are some researchers who are very concerned that KivuWatt's operations and similar companies doing the same thing might end up triggering the very limnic eruption that they are attempting to mitigate. The KivuWatt operation, over time, is probably going to somewhat alter Lake Kivu's structure. Some researchers argue that Kivuwat's operations might end up punching a hole through the narrow, centimeters-thick layers in the water and enable the gas-rich lower layers to penetrate up into the upper layers and escape, potentially triggering the limnic eruption in the process. Others argue that the potential consequences of this methane extraction in the lake might not make themselves readily apparent for decades, and that the risks outweigh the potential rewards. Still, other researchers insist that the operation is completely safe, and that Rwanda has a great need to harvest the lake's methane as a rare, domestically available fuel source for electricity in a deeply impoverished developing country. Nonetheless, while Lake Manaun showed the world the limnic eruptions were possible, and Lake Nyos showed the world how catastrophic they could be, Lake Kivu still retains an even greater potential for death and destruction, despite how peaceful and tranquil it can appear on the surface today. With an ongoing armed conflict going on around the lake that has claimed thousands of victims, the potential for a limnic eruption happening at Lake Kivu still retains the potential to one day kill millions of more people who live around the troubled lake's shores. And regardless of how likely that might be one day, the mere possibility that it could happen is, in my mind, what makes Lake Kivu the most dangerous lake in the world, and probably the most destructive natural disaster that is just quietly waiting to maybe happen one day. And while there's a lot to be concerned about living around Lake Kivu, there's also a lot to be concerned about while living in the United States these days as well. You may not know this, but America has some of the weakest privacy and data protection laws anywhere in the developed world, which means that relative to other countries, there's a ton of Americans' personal data that just gets put out into the public record, sometimes even by federal, state, and city governments themselves. This has always sort of been the case here, but it never really became a critical issue until the advent of the internet, when people began being able to make money by making it easier for other people to get a hold of your personal data. These people and the websites they create are known as data brokers. They're private companies that collect and then sell your personal data that they scrape from publicly available records like electoral rolls and census reports. And there are hundreds of these kinds of data broker companies probably selling your personal information right now. These companies could have your name, phone number, address, shopping habits, and possibly even your social security number that's all available to the highest bidder. I know that when I checked myself and typed in my own name, there were literally hundreds of different companies that had this kind of information up for sale to other companies, scammers, stalkers, or even worse. At best, this situation leads to frequent scam calls and spam emails, and at worst, it can lead to doxing, phishing attempts, or even identity theft. Data breaches are getting more and more common every year, and especially if you live in the United States, you straight up don't have any federal protection from these kinds of companies whatsoever. But this is where this video's sponsor Incogni comes in to help. Incogni will fight on your behalf to remove your personal data from data brokers, and they'll deal with any objections that come from their side. All you've got to do is create an account and give them your approval to work on your behalf. Incogni will then carry out repeated ongoing removals, because even if the broker removes your data once, they can always just collect it and then sell it again. Incogni will repeatedly fight to make sure that your personal information stays off of the market permanently. I know that when I signed up, it was horrifying to see how many brokers out there actually had my data. But then it was also so satisfying seeing Incogni getting them all deleted one by one. And I've seen a huge decrease in the number of spam calls and emails that I've gotten ever since. So if you'd like to give Incogni a try as well, you can do so by clicking the button here on your screen right now, or by going to incogni.com/reallifelore, where you can use the code RealLifeLore to get an exclusive 60% off of an annual Incogni plan. You'll also greatly be helping to support my channel at the same time. So once again, that's incogni.com/reallifelore and code RealLifeLore for 60% off of an annual Incogni plan. And as always, thank you so much for watching.